Today's lecture is on the rate equation for the complex reaction. Before seeing that discussion, I have forgotten to give one type of problem, that is Arrhenius rate equation. That problem has been given in the board. Just take down the problem. A catalyst lowers the activation energy of a reaction from 83.31 to 75 kilojoule per mole at 500 degree Kelvin. What will be the rate of the reaction as compared to uncatalyzed reaction? That is, they want the ratio of the rate of the reaction by the catalyst to the rate of the reaction to the uncatalyzed. Assume other things being equal. How to approach the problem? You can approach either using the exponential equation or in the logarithmic equation. But this type of problem can be easily solved taking the exponential. Therefore, I have taken the exponential equation k is equal to r into a into e power minus e by rt. Instead of k, I have now written this as the rate because the rate is given, rate of the reaction. I already given say the rate of the equation, or rate constant can be given in that place. Then I have put the data, given data for uncatalyzed reaction first, RU. RU means rate of the uncatalyzed reaction. Here I have substituted only the energy of activation as 83.3, and the ray R is a constant, T is at the same temperature 500 degree Kelvin. Then I have substituted the data in the catalyzed reaction, for which I have changed the rate as C, that is equal to A into e power minus 75 by RT. Why I have put A here and here the same? Because assume all other things being equal. Therefore, now we have to find out the rate of the reaction of the catalyzed by the rate of the reaction by uncatalyzed reaction. Therefore, I have put the rate of the reaction, catalyzed reaction, the numerator, and the uncatalyzed in the denominator. If you do this, you will finally get this equation, e power 83.3 by RT into e power minus 75 by RT. If you take this, say 83.3 minus 75, because RT, denominator is same, RT, therefore you will get 8.3 by RT, and here the 8.3 is given in kilojoule per mole. Therefore, R should be in kilojoule. Here we have written is in a joule. Convert it into the kilojoule. We are multiplying it by 10 power minus 3 into the temperature is already 100 degree. Therefore, I have put the 500. This 8.3 and 8.3 cancel, and 10 power 3 going upward, this 1000 divided by 500, you will get the e power 2. See whether the answer is given in e power 2 or some other value. Here it is found that the e value is given in numerical value. Therefore, you have to find out what is e power 2, for which you use your own calculator. E power 1 you already know, it is equal to 2.7. Therefore, e power 2 is nothing but e power 1 power 2. Therefore, instead of 2. E power 1 is 2.7 square equal to 2.7 into 2.7. And multiply the square by our methodology, you will get 7.2. This is an approximate value, and it is 7.4 is the value given. Therefore, option C is the correct one. We will start our today's chapter, that is rate equation for a complex reaction. Here in this also, a variety of questions will be asked. and how to solve this. We will easily solve this. So far we have derived the rate equation for simple reactions or elementary reactions. What is meant by simple reaction? What is meant by elementary reactions? You know the difference between these. The elementary reaction is one in which one elementary reaction is one. For example, 2A giving products is taking place in only one state. The reaction is taking place in one state. That is, reactants react among themselves to give the products in a single state is called the elementary state. On the other hand, if a reaction takes place more than one step in one state, such reactions are called complex reactions. Is there any way to distinguish a simple reaction or elementary reaction, complex reaction? Theoretically, we can be possible for some cases, but for all cases, it is not possible to distinguish this. What is the simple things by which we can differentiate one? For elementary reaction, you can calculate the molecularity of the reaction. You know what is maintained. So far, I have not mentioned anything about the molecularity of the reaction. And the molecularity, you know, molecularity of the reaction is the number of molecules taking part in the reaction in the rate determining states. And the rate determining state for the elementary reaction is the 1 and 1 state. And how many molecules are reacted, that is also equal to the order of the reaction. Therefore, this is a simple way for it. You can distinguish whether it is simple reactions or elementary reactions or complex reaction. But in complex reaction, as you have written the stoichiometry of the reaction equation, stoichiometric equation, the number of moles present, number of reactant molecules present will not be equal to the order of the reaction. In elementary reaction, the order and molecularity may be same. So here, it should be same, not should be same, it may be same. Because in some elementary reaction, order and molecularity are different. I will tell you one order, I will quote one or two examples. But in complex reactions, always there is a difference in the order and molecularity. In a simple elementary reaction, when the order and molecularity are changed, already we have seen the ester hydrolysis. In the ester hydrolysis, according to the stoichiometry, it is a simple reaction taking place in a simple state, therefore it is called elementary reaction. And here, one molecule of acetate and one molecule of water is undergoing reaction. Therefore, the molecularity of the reaction is 2. If it is an elementary reaction, we can expect the order also. The order with respect to ester is 1. Order with respect to water is 1. Therefore, we are expecting order 2, and the molecularity and the order is the same for elementary. But in the elementary reaction, this generalization is met with a failure when one of the reactants is taken in large quantity. It's taken in the large quantity. You already know it. And such reactions, now the order of the reaction is the first order with respect to ester, because concentration of water is not a ground shape. And such reaction, you should not immediately call that the ester hydrolysis is a complex reaction. No, it is taking place in single state. Therefore, your order and molecularity are different, but under what condition they are different? Here you have taken water in excess, therefore don't classify this reaction under the complex reaction. But classify the reaction and pseudo-order reaction. Classified under pseudo-order reaction. It is taking place in single state, but order and molecularity are different. Such reactions are pseudo-order reaction. If the order and molecularity are different, but takes place in a number of steps, then you classify such reactions as complex reactions. The complex reaction, you are going to give a number of steps. For example, A plus B plus C giving product. Whether this reaction is taking place in a single state or it takes place in a multiple states, single state or in a multiple state. And in a multiple state, you should write down the reaction. A reacts with B, giving AB. First, a product is formed. This AB then reacts with this C to give the product. Now, from the steps also we can say that it is a complex reaction. And for such a complex reaction, what would be the rate law equation? You have to write down the rate law equation. How to write down the rate law equation? And but one condition is the final rate law equation should consist of the constituents of the reactant constituents only. What do you mean by reactant constituent? Final of the reaction should contain only in terms of A or in terms of B, in terms of C. These are called the reactant constitutions. A, B, C. It should not be in terms of the intermediate forms. At any time, no intermediate should be present in the rate law equation. Or sometimes it may be having the product concentration also. It is allowed. Product concentration, it is allowed. But in the rate law equation, no time, any intermediate should not be present. But in complex reactions, we are going to write down the rate law equation only in terms of the intermediates. Therefore, the intermediate concentration should be converted in terms of the reactant concentrations and the product concentration. How to find out the two methods are adopted. One is called the equilibrium approximation method, and another is called steady state approximation method. Using these two methods, you can calculate, can find out the rate law equation. Once the rate law equation is obtained, then from which you can work out a number of problems. What are them? One can give more number of mechanisms for the same reaction. First, collect the kinetic data. And for these various states, you can finally give a final rate equation. Apply the rate law equation to the observed kinetic data. Which one gives the correct, interpret the correct kinetic data? That mechanism is taken as the correct mechanism if you give more number of mechanisms. If the predicted mechanisms are not giving the correct interpret the correct kinetic data, then you have to formulate some other mechanism. Now let us give one equation 3A plus 2B giving the products P and Q. This is the short geometry of the reaction. If it is a single step, the molecularity should be 5 and the order should be a 5th order. But as the order increases, the example for such a reaction is becoming less and less. And so far, 4th order reactions have been discovered. The 4th order is having only 1 or 2 examples are there. And therefore, what is the molecularity of the reaction? How to determine whether this reaction is single step reaction or multiple step reaction. Find out the molecularity and the order. Here the order and molecularity are definitely different, not as given by the stoichiometry. Here now let us assume these reactions are taking place. Let us predict that these are the following states. A and B first reacts to give C and D. Here look out, A, B are the reactants. B and Q are the products. In the rate determining step or rate law equation should contain only the concentration of A, concentration of B, or concentration of P and Q. These are called reaction constituents only present. Whereas here the C and D are called reaction intermediate. That reaction intermediate should not be present in the rate law equation. And we are going to see that during giving the rate law equation, we are always coming across the intermediate in the rate law equation. You should suitably substitute the concentration of the intermediate in terms of the reactants or in terms of the products or in terms of both reactants and products. How to arrive at the rate law if several steps are given. And I am also writing the A and the C formed in this step is reacting with the reactant A giving E. Here E is also another intermediate. A then reacts with the D, the another intermediate D to give F. The F is also another intermediate. The E plus F gives P plus Q. These two intermediate reacts to give the products ultimately. Here, the stoichiometry of a reaction is given. Therefore, immediately we can say that A, B are reactants, P and Q are products. But in some question problems, they won't give the stoichiometry of the reaction. They will reaction follows in the following steps. They will give like this. And how to determine whether these are the reactants, whether these are the products, which are the intermediate. That can be easily seen. And the reactants are only those species which are present in the left-hand side itself. It would not be coming to the right-hand side. And the products would be in the right-hand side of the equation. If you look at it here, see, here in the first step, it is in the right-hand side of the equation. And in the second step, third step, they are all present in the left-hand side. The species which are present either in the right, both as well as in the right as well as in the left, would be the intermediate. Therefore, based upon this, you can boldly say that A, these are the reactant. B, it is present only in the left-hand side reactant. P and Q are present in the right-hand side. Therefore, these are the products. Whereas C, D present both in the left and right. E and F present in the right and left. Therefore, the four species are in the intermediate products. They are called as a transient species. Why they are called as a transient? Transient means unstable. Transient species means unstable. And only these transient species we are going to apply steady state hypothesis. You know that hypothesis very well. Okay, otherwise we will see in the short while. And in these steps of reaction, each steps return is called elementary steps, elementary reaction. Here the speed of the four reaction steps are not at all equal. One may be having higher, one may be the lowest. Some other would be having almost the same and so on. And to arrive at the concentration of the intermediate, we are going to apply two approximations. One approximation is the equilibrium approximation, and another is the steady state approximation, equilibrium approximation, and steady state approximation. When will you apply an equilibrium reaction? If the steps involved in the multiple steps, one of the steps or two steps may be attaining equilibrium, then you can apply the equilibrium method. But no steps are involving the equilibrium, then you should go for steady state approximation method. Therefore, whether equilibrium approximation is to be adopted or steady state approximation is to be adopted, we can easily see by the way they have presented the steps. Okay, now this is steps that are all given, and if you sum up the overall steps would be 3A, will give you the stoichiometry of the reaction. That's the stoichiometry of the reaction. And you understand this. And each step have its own rate constant or rate, K1, K2, K3, K4. And each step would be having its own free exponential factor or the Arrhenius factor A1, A2, A3, and A4. Each step would be having its own activation energy E1, E2, E3, and E4. And what is the net rate law equation? The rate law equation R is equal to K, the overall reaction, into the concentration or the constituents of the reactants and products. They will be present. If the intermediates are present in the rate law, they should be suitably substituted with the concentration of either the reactant or the products or both. Finally, after arriving at this rate law equation, then you can calculate the overall rate constant will be given in terms of this one. Then you can apply the Arrhenius equation to calculate what is the overall Arrhenius parameter. Then you can apply the Arrhenius equation to calculate what is the net activation energy for the complex reaction. First, we will see how to derive the rate law equation. From the rate law equation, how we can calculate the Arrhenius parameter and how we can calculate the energy of the activation energy of the complex reaction. This can be easily calculated. First, we will derive the rate law equation by taking a simple equation. Then we will go for complicated reactions. Or I'll take down this one. Given the steps O3 with a reversible arrow giving K into O2 plus O, the fast equilibrium. Second thing, O3 plus O giving K1 giving 2O2 is the slowest state. And I have forgotten to tell you one thing. In multiple step reactions, that is for a complex reaction, which is the rate determining state? What is the rate determining? Sorry, which is the rate of the reaction? Rate of the reaction. You have seen that K1, K2, 4 steps in the last example, and K4. Which is the rate determining state? Generally, the reaction is taking place in multiple steps. The overall rate is not a sum of all these rates, but it is determined by slowest step. Therefore, in a complex reaction, which is the rate determining step, the rate determining step is nothing but the slowest rate step is the rate determining steps. And rate determining step, and from the taking from the slowest step, we can write down the rate law equation because that is the rate determining step. And how many molecules are involved in the rate determining steps, that is the molecularity of the complex reaction. And what is the order of the reaction, that can be decided only after giving the rate law equation. Therefore, if you quite understand this, now whether you can apply the equilibrium approximation and or steady state approximation, that can be easily done. Here, one of the reaction steps, one or more steps would be attaining equilibrium very fast. And another reaction is said to be slowest step. And whether we have to apply equilibrium approximation to find out the concentration of the intermediate, or we have to apply a steady state approximation, for which you should find out the speed of the each step. Here it is a fast equilibrium, and here one step it is given as the slowest step. Therefore, now there is the equilibrium reaction is present, and the slowest step is also present. And you apply a rate determining steps or rate law from the slowest step. And if the slowest step, the rate equation involves, now let us assume the slowest step. What is the rate of this reaction? The rate of the reaction is equal to the rate constant given as K1 into the concentration of O3 into concentration of O, the intermediate. I have already told you that the rate law equation should consist of the reaction constituent, not reactant constituent, reaction constituent. What is a reaction constituent? Either the reactants or the products, because that species will be the stable species. But here the intermediate species we return is unstable, transient existing is there. Therefore, you should suitably substitute the concentration of O in terms of the reactants or the products. Here, what is the reactants present in this reaction? Here, no stoichiometry is given. However, you can find out the reactant and products. Which is the reactant here? Tell me the reactant.
O3.
O3 is the reactant because that is present only in the left-hand side of this. What is the product? What is the product?
O2.
O2.
Which is the intermediate, which is present along either in the O is there. Therefore, here in the rate equation, O is there, and the O should be replaced. And how to you replace the O? That O can be replaced if the fast equilibrium is present, and in which the O is present. You can calculate the concentration of the O from that step. Here, the equilibrium of a reaction is given by the concentration of the product into the concentration of the reactant. If you use this, that is called as Kc, but here it is given as K alone. Therefore, we will also put it as K, and K is this one. From this, you can calculate the concentration of the transient species, that is unstable species O, K into O3 by O2. Now substitute the concentration of O to the rate equation. Now rate is equal to K1 into O3. In the place of O, you have to write K O3 by O2. are equal to K into R1 into O3 concentration square into O2 concentration power minus 1. Now, our rate equation is given in terms of the stable species, the reactants or the product or by both. Therefore, it is a correct rate law. But this is not the correct rate law because it involves the transient species. Accordingly, this one, now the overall rate is given, overall rate constant is given by K into R1. And what is the constant? What is the order of the reaction? The order of the reaction with respect to ozone is the second order reaction. According to this equation, with respect to the product, it is a minus one order. It is a minus one order. This is the equation given. Now let us apply the same thing in another manner. What is the another manner? Take down the one. A reaction takes place in two steps. A reaction takes place in two steps. Given as K1 rate of the forward reaction and K of the backward reaction, O2 plus O and O3 plus O giving K2 2O2. Here given like this only. Compare this steps mechanism with the previous one. In the previous one, in the second step, in the bracket, we have given it as a slowest steps. Here, whether the K1 is a slowest step or K2 is a slowest step, or both of them are in equal rate, more or less the same rate, we don't have any idea. If such a mechanism is given for any problem, you should go for the steady state approximation. You should go for a steady state approximation. How to apply the steady state approximation for this? Once again, in the steady state approximation, you have to calculate the intermediate concentration alone, that is sufficient. Or you can, under mass balance equation, அப்படின்னு ஒரு technique இருக்கும். They would tell you that write down the mass balance concentration for each species present. Here, what are the species present? Ozone is a species present here. Another species, O2 is a species present. And another species is O is a species present. Only three species are present. You can, if 4 or 5 species are present, you have to write down all the species concentration. What is the concentration of ozone? What is the concentration of O2? What is the concentration of O? To reduce the time, you not necessary to write down the concentration of the stable species. It is sufficient to write down the concentration of the transient species or intermediate species. Here we will write down the concentration of the intermediate species that O is formed in the first step from the ozone. Therefore, it is formed. Therefore, we are putting plus in the K1 into the concentration of O2. And this O2 is concentration is reduced due to the backward reaction. Therefore, the concentration is reduced at the rate of K inverse 1, and concentration of O2 here depends upon the concentration of O2 as well as the concentration of O. And here in this step finish, and in the second step, once concentration of O is decreased, therefore minus K2 into the concentration of ozone into concentration of O. Here, initially, the concentration of O is small. As reaction is going on, the intermediate concentration is going on, increasing. At one particular time, the formation of O would be equal to the disappearance of O. Formation of O is equivalent to disappearance of O. At that condition, we say that the concentration of O attains the steady state. The concentration of O attains the steady state. At the steady state, the rate of formation of the O would be equal to the rate of formation, consumption of O. That we call it as the steady state. And the steady state, the concentration of O would not be undergoing changing. It is remaining constant. Since it is remaining constant, when you differentiate a remaining constant concentration with respect to time, it is becoming zero. A constant differentiated will give you zero. Therefore, here now we have applied the steady state approximation for the determine the concentration of O. Therefore, instead of this O is equal to K1 O3 minus K minus 1 O2 plus K2 O3 into the concentration of O. Or the O can be, concentration can be written at, bring the terms in the other side and find out the O value. It is K1 O3 divided by K minus 1 concentration of O2 plus K3 into concentration of O3. And what is the rate law equation? How to find out the rate law equation? The rate law equation here, the slowest step is not given, and you have to, what is the rate law equation? And if, we will give it in terms of minus of d of O3, the rate of consumption of ozone is equal to the rate of formation of O2 by dt. It is the rate of the reaction from which you can give the rate law equation. Therefore, to find out this one, or to find out this one, you have to also find out the rate law equation, O2 concentration by dt, for which you have to find out what is the concentration of O2. It is obtained as the rate is equal to K1, the concentration of O2 is equal to K1 into O3. This is the formulation minus, it is consumed in the reverse reaction, therefore K minus 1 into concentration of O2 into O. And it is also here in the second step, it is formed, therefore K2 into the concentration of O3 into concentration of O. And now this rate law equation consists of the unknown, the transient species O. Substitute the concentration of O in this place, you will get the rate law equation. We will now apply this in this equation. You will get what happened to this one. You can simplify this equation as O2 is equal to K1 O3 minus K minus 1 into concentration of O2 minus K2 into concentration of O3 into O. In the place of O, you have to substitute this one. And the applying steady state approximation would take you a longer time. But a simple method is also there. After deriving this, you will be able to sketch some of the shortcut in giving the rate law equations. And first we will see how to write down this rate law equation in lengthy, then we will see in shortcut form. Substituting the O in this, you will get the rate of the reaction. Rate is equal to K1 O3 minus K inverse 1 O2 minus K2 K2 O3 K1 O2 plus K3O3. It's a long process, I have already told you. And finally, you will get, on simplification, you will get K1, K2 into O3 square by K2O3 plus K inverse 1 O2. This is the equation you have obtained. That obtained from applying equilibrium method. The equilibrium method, you have calculated this. The rate is equal to K1 into K into O3 square by concentration of O2. Now compare these two, one a somewhat different one, because that only one step is the slowest step. We have taken that one and it's a simple method. And here it is a 1. And if you take this one, K2 into O3 is the slowest step, your equation will be changed. Take K2 is very, very greater than K inverse, then you will get another type of rate. Or applying condition K minus 1 is very, very greater than K2, you will get some other equation. Therefore, in the steady state approximation, you can give rise to one or two cases. If this is the condition prevailing, what is the rate equation? If that is the condition prevailing, what is the rate equation? And this is the methodology. And we will see some of the examples how to write down this one as easily as possible. Take down this one. 4 HBr plus O2 gas giving 2H2O plus 2HBr. Given the steps HBr plus O2, K1, HOOBr. This is the slowest step. Then HOOBr plus HBr, K2, 2HOBr is the fast step. 2HOBr plus HBr and K3 giving 2H2O plus 2Br2 fast step. Give the rate equation. Here, one step is indicated as the slowest step. Therefore, you can adopt a equilibrium method approximation to this. But here, no such reaction is attaining the equilibrium. Then whether you have to go for then you can go for the steady state approximation. Before applying the steady state approximation, we will apply the rate equation for the slowest step. What is the rate equation for the slowest step? Rate is equal to K1 into K1 into, tell me,
Concentration of HBr into concentration of O2.
constant HPR into concentration of O2. And look at the rate equation. Is there any transient species present or not? Is there any transient species present
Yes,
or
sir.
not? Any transient species?
Yes, sir. HOOBr.
No. I am asking you in the rate equation.
No,
In the
sir.
rate,
Okay, sir. In the
any,
retake, no,
any
sir.
no transient species is present. Therefore, this is the rate law equation. No necessity of applying the steady state approximation. Now, your rate is a second order reaction, first order with respect to HPR, and first order with respect to O2. Therefore, writing in the slowest step, the rate law equation, find out whether you have to go for further to find out the concentration of any transient species or not. Okay, then take down another one and we will see how the another thing is taking place. Take the reaction A giving B. A intermediate under equilibrium to give I. It is a fast reaction and it is K1 and let it be K2. The I then react itself, the rate constant is K3 to give B and it is the slowest step. And anybody can tell me what is the rate law? Work out and find out the answer. What is the rate law or what is the rate law equation? Rate is equal to apply.
K3 into concentration of I, sir.
K3 into concentration of I. Okay. Here whether we can leave the rate equation as or you
We
have
have
to
to proceed
proceed
further,
further.
sir.
Why?
Because transient species are present, right, sir?
And how to attain the concentration of the transient species?
Through equilibrium.
Equilibrium. Apply the equilibrium condition. Find out the concentration of I. Now what is the rate equation?
Equilibrium rate is equal to concentration of I divided by concentration of E, sir.
And write down concentration of K1 into concentration of A by concentration of K2 is not. Substitute, you will get K3 into K1 by K2 into the concentration of A. Whether this is a correct rate law equation or we have to proceed further. No necessity. Why? A is the reactants, a stable species. With this, you can stop your work.
Sir,
Oh, yeah.
சார் அந்த ஐயோட கான்சன்ட்ரேஷன் வந்து சப்ஸ்டியூட் பண்ணிருக்கோம்ல சார் அது மட்டும் கொஞ்சம் எக்ஸ்பிளைன் பண்ணுங்க சார்.
Sorry, how do you determine the concentration of I? The I concentration should be derived from the equilibrium because fast equilibrium is there. Once again, the K1 by K2, it is the equilibrium constant. K1 by K2, K1 by K2 is the equilibrium constant that is given by the concentration of the product divided by the concentration of the reactant. Therefore, the concentration of the product is equal, I is equal to K1 by K1 into A by K2. And what is the overall rate constant of the reaction? The overall rate constant K overall is equal to K3 K1 by K2. And What would be the overall? What would be the overall Arrhenius factor for this reaction for which you should apply K overall is equal to A overall into e power minus E overall by RT. How to find out K overall? For which here write down K3 is equal to A3 into e power E3 by RT.
Excuse me, sir.
Yeah,
Why are we using equilibrium approximation instead of steady state approximation, sir? I'm not getting.
here steady state approximation. Here you have to apply the simplest method equilibrium because one step is the slowest step for which you can write down the red law. And here the intermediate I is formed that is present in equilibrium. Apply the equilibrium approximation. You can easily find out the concentration. Instead, if slow step is not given, now you should go for the which method? Steady state approximation method. Here K3, K1 rate, which is faster, which is slower, we don't know. Then you should apply for the steady state approximation. Do you follow this?
Yes.
Here you should apply this. Here one step is said to be slowest step. Therefore, we are applying the equilibrium constant method. Therefore, here you have obtained, this is the rate law equation. In this rate law, this K3, K1 by K2 is called the overall reaction rate constant. K overall is equal to K3, K1 by K2 into concentration of A. Now we are going to calculate K overall is known. You can calculate the Arrhenius frequency overall. What would be the Arrhenius frequency overall value? What would be the energy of activation? What would be the energy of activation, overall energy of activation? That can be calculated. Here, A overall minus E overall by RT. You have to find out, you may be asked to give the A overall for this reaction, that is Arrhenius factor. This A is called reactant concentration. Here we put the Arrhenius frequency. Overall Arrhenius frequency is what? And similarly, you may be asked to calculate the energy of activation for the overall reaction. That can be easily calculated. Apply Arrhenius equation for each steps. For K3, for this K3 is equal to frequency factor is A3, that is Arrhenius factor is A3, e power. For the step, the energy of activation, we take it as E3 by RT. Similarly, you can write here in this rate equation, it is present K1. K1 can be written as, tell me, K1 is equal to, tell me.
A1 into
Uh,
E power
uh.
E1 divided by RT.
Then next one, K2.
K2 is
Here
equal
K2,
to A2 into E power minus E2 divided by R2.
RT. Okay. Now overall means K overall is given as this one. Therefore, you should multiply K3 into K1 and divided it by K2. If you substitute like this, you will get is equal to K3 instead of K3 put A3 into e power minus E3 by RT into K1 A1 into e power minus E1 RT by RT divided by K2 divided by A2 into e power E2 RT. Therefore, if you rearrange this A3 A1 by A2 into e power minus E3 minus E1 plus E2. The energy of activation overall by RT. The energy of the, now you can calculate what is the A overall, that is A overall is equal to this much. What is the energy of activation overall? That is E overall by RT is equal to E minus E3 minus E1 plus E2 by RT. This RT cancel, minus, minus, plus and minus. And now your value is equal to E3 plus E1 minus E2. This is the overall energy of activation. To obtain the overall frequency, you have to multiply as given in this. K3 in the numerator, A3 should be in the numerator, K1 in the numerator, A1 in the numerator, K2 in the denominator, therefore A2. This is the overall frequency. And to find out the energy of activation, overall energy of activation, E3 in the K3 in the numerator, corresponding E3 should be positive. K1 in the numerator and corresponding E1 is also positive E1. And K2 in the denominator, the corresponding E2 is minus 2. It is the overall energy of activation. This is the derivation. This is the derivation. Hereafter, in applying this derivation, you need not to apply this derivation. You can simply tell what is the overall energy of activation, if at all asked. If you understand this, I will give you one thing, and you should give the able to give the energy of activation for the process. The K overall is equal to K3, K1 square, K4 power r divided by K2 power 2 by 3, K2 power 2 by 3. This is the overall rate constant. Let us assume. Then what would be the overall frequency factor or the Arrhenius factor? A is equal to, anybody tell me the answer? A overall would be anybody.
A overall is equal to A3, A1
A3,
square,
A power
2, and
2,
A4 power 1 by 2,
1 by 2,
divided by A2 power 2 by 3.
Yes, you are right. And what is the E overall for the net to complex reaction? What is the energy of activation? Tell
E3,
me. E3
plus E1
plus E
square.
Plus E1 square. Plus E1 square, right? Yeah, or any other things. எப்படி போடணும்
சார் ஃபர்ஸ்ட்டுமே மைனஸ் E3 தானே சார் வரும்?
மைனஸ் E3 எப்படி வரணும்? கொஞ்ச நேரத்துக்கு முன்னால என்ன போட்டிருக்கேன்னு பாருப்பா. கண்டுபிடிச்சிட்டியா? The numerators இருக்கிறதெல்லாம் பிளஸ், டினாமினேட்டர் இருக்கிறதெல்லாம் மைனஸ்ன்னு சொன்னேன். இஸ் இட்? ஹலோ, கேட்டது யாருப்பா?
எஸ் சார், எஸ் சார்.
அண்டர்ஸ்டாண்ட் பண்ணிட்டியா?
எஸ் சார்.
Then now write down the energy of activation for this. How to write down the energy of activation? சொல்லுங்க பார்க்கலாம். K1 square இருக்கு. Energy of activation எப்படி இருக்கும்? Plus
2K1
plus தானே? Hello?
2E1
Okay, then
plus
yes, you are
half
right.
plus
Half
E4
okay, next
minus 2 by 3
divided by
minus 2 by 3
E2.
E2. This is the overall reaction, energy of activation for the complex reaction. Therefore, I think you have now understood the concept of this. Thank you very much. Have a nice day.